Hello everyone, we're going to talk about a very simple design pattern. Today is the factory object, or some people call it the simple factory object design pattern. And this is not proposed by the Gang of Four, just to be honest and to be frank with you. This is not one of the Gang of Four design patterns. The Gang of Four, just as Dr. Ahmed mentioned, are basically the four software engineers who came up with all of the known design patterns that we are actually studying in our course and in other software engineering courses. So the Gang of Four came up with a slightly different version of or a more sophisticated version of the factory pattern. They came up with what we call a factory method design pattern, right? I'm going to show you the differences between both of them. Essentially, this needs just a single class, a single factory object or class that's going to do the conditional instantiation or conditional object creation. But here we refer to the subclasses to do the conditional creation. If you don't understand what is conditional creation, this is just basically means an if statement contains a creation of a certain object, right? So let me show you what I mean. Okay, let's say that to just let you understand what is a factory pattern, so I'm just going to say exploration.ipymp, and this is a quick Jupyter notebook. Okay, and let me just run this cell. Alright, so let me have something that you are familiar with. I'm just going to start with the generic example first. Let's say that I have a class called A and I have another class called B, right? And there is some kind of a conditional, right? A conditional, an if statement that decides when to use A and when to use B. Let's say that this conditional is going to be a variable like type, right? So if the past string if type equals, for example, A, right? So this means that I'm going to create an object out of A, right? And I'm going to have a return value, which is going to be for the time being as none, and I'm going to return this return value, right, regardless if it's A or any other class. Elif, and that's the other case, what if the type, what if the type was actually B, for example, because these are the only two classes that we have in the namespace. So if I think you can guess now what it's going to be looking like, so I'm just going to create another object of B. By the end of the day, I'm just going to say that this is the object of B, right? This is the conditional creation. This is what we mean by conditional creation. Yeah, and by the end of the day, we are going to have either an object of A or either object of B based on the past string or the past type. So this is conditional creation. Conditional creation just means that an if statement, right, based on a single condition, I'm going to create a certain object, and based on another different condition, I'm going to create another different object, right? So conditional creation can be encapsulated, as we know, inside a function. Let's say that this function is going to be conditional, or let's just say just name it create object, right? And create object essentially needs to have a type, right? So if we have everything inside this function, we can just say that this is going to be returning what? By the end of the day, returning the return value, right? Which is essentially the created object. Actually, I can call this object and we're good to go. Okay, let me just write this really quickly. So it's so let's just call it created object, right? So how does the simple factory looks like? The simple factory essentially looks like this. This is the function that does what? That does the conditional creation. Now the simple factory is, from the name, the simple factory object is just having a class, right? A simple class that contains just one method that does the conditional creation, right? So instead of having this function just freely like this, I'm just going to say that this is inside a class, and I'm also going to call this factory object class, right? And I'm just going to define this as a method inside this factory object class, right? So I'm just going to say, since this the method it takes a self, right, and it takes a type, okay? And this is all what is the symbol factory is about, right? So if I want to try that, right, we can just say that I'm going to create an object of the factory. I'm going to say this is my factory object, right? And this is my client because I'm just trying I'm trying things out here. So if I have the factory object, I can just say create object, and based on the past argument, right, A or B, we are going to have a certain return type, right? So I'm just going to show you what is the return type based on the created or the past argument. So I'm passing A, so the return type is obviously an object of A class, right? So how does this look like in a class diagram? Simply, if I'm not going to modify what we have done so far, but in a class diagram, things are just going to look like this. So this is your factory. Essentially, you don't really need anything in the symbol factory, so I'm just going to call it factory object, right? You don't really need to have any variables right here in this area. What you really need to have is the creation method or the creation function that does the conditional creation. I'm just going to call it create object or create factory or whatever, just name it create object, right? And this, you know that it's should be a public thing, and I'm just going to set this like that, and it takes essentially a type, right, or a string or a conditional parameter, and this is going to be of type string, and it returns a certain object. So what is the type of the thing that it returns? This depends on of what are we conditionally creating, right? So let's say that this is going to be connected to a product, to a single product, right? So let's just say that this product is going to be the following, right? We can say that it can be connected to this product. So this is product A. Product A can be class A, like the one that we have seen here. And just to give you concrete examples, imagine that class A is essentially a JSON kind of database, right? Because this is the kind of use case that I'm going to follow, right? And this is, for example, another kind of storage, which is MySQL database, right? So these are two types of storage. What happens if we decided to change the storage in our system? So we need to have some kind of a data access that handles JSON operation. What if we change the storage into to an upcoming sprints in the future? We decided to change entirely the engine to MySQL, right? So this means that the data access layer that we have defined that contains the CRUD operations should be redefined to handle CRUD syntax and query syntax, right? Okay, so this is one case scenario. What if in your expense tracker you have a finance, and your finance can be either expenses or incomes, right? Something that is decremented or something that is incremented, added or subtracted. So in this case, the first concrete product can be expense, right? And the other concrete product is going to be income, and there should be a function that decides whether you are going to create an entity expense or an entity income, right? Or if you don't really have any ECB pattern that like the one that we have refactored. I'm actually continuing on the previous lab. We refactored everything to ECB, so you can see that there is entities inside data access, there is controllers right inside business logic, and there is boundaries for each controller that we have created or for each entity that we have created in our presentation. But anyways, if you don't have ECB and you're only having two classes, right? So this is essentially your domain object. Like this was the case before the ECB, if you remember. The case before ECB, it looked something like this. We just had domain objects, so a class that contains everything, all of the use cases as methods, just like this. We didn't separate any use case into its own controller. So what if this is the case? I just have all of the code related to account encapsulated in one domain object class. Then all good. You're still going to need some kind of a conditional, right? Maybe this conditional is going to be this if block. Maybe this is going to be scattered all around the code, right? Or maybe it's going to be encapsulated within a function, or maybe it's going to be encapsulated within a method within a class. So in this case, you're actually implementing the symbol data factory or the symbol factory object, right? To choose between expense, to choose between income. So that's essentially the logic of the symbol access, symbol factory object. Okay. So continuing, and to show you just what this looked like as a class diagram, we can just have, I don't know where did we create this, it's here. So this is class A, which is a single product, right? By the definition of design patterns, this is a product. This is considered to be product A or product 1, and this is product 2. And this is a type of product that this factory is going to be creating via, right, via the method here. This what matters in this class, in this factory object class, right? Or you can say that the factory can either create this or create this class, which is another type of product. And you can have multiple types of product. It doesn't have to be A and B, right? Now what really matters here is that you can actually say, if you know that product A and product B of some sort, they are of the same kind, since you can refer to inheritance in this case, you can say, for example, that there is a parent or a base class, right? And this is your base class, and we can just say that class A inherits from base, inherits some attributes, inherits some methods, but they are kind of the same kind. In case of expense and income, both of them can be referred to as finance, right? So you can refer to this as finance, income, and or expense and income, just like that. Okay, so if you know that this is the case, then we can just say that the type that is being returned, which is a created object type, it's going to be either A or B. This is what we know, but something to add on to the cherry on the top is that if A and B are of type base, then I know for sure that the created type is going to be of type base, whether it's going to be specialized type of A or specialized type of B, right? So there is something to denote this kind of return value in Python. It's an optional thing, but you can just say that both of them are going to return a base type, right? Which is simply a data type, a custom user-defined data type that we just created, right? If you don't want to have this notation, if it messes up the highlighting for you, then just you can omit it. Just as something like in C++, whenever you say that create object returns something, so you need to specify the return value before the name of the function. So you say void, you say integer before the name of the function, before the definition here, and it's essentially the same thing as saying that this function is going to be returning something of type base, but this is Python, so we don't really need that, right? Anyways, continuing, if I know that both of them are of the same kind of products, then essentially I can just have a class and I just can call it base product, right? And base product essentially is going to be the parent class, which have this concrete products being inherited from it, right? Which have these concrete products inheriting from it, right? So that's inheritance. This is the base. In my case, I can just remove the line from here, and we can just say that the factory method, let me just take this part and put it here, right? The factory method is going to be either creating an object of B or A, which by the end of the day, they're just a type of base product. So the create method, the create object method, which is in the factory method or the factory object pattern, is going to be returning a type of A or B, which by the end of the day is just a type of A, of base product. So I can just say that it is a type of base product. This is the return type of this method, right? Now this is not an association, because if you take a look here, we said that if you have any object creation, this is object creation, right? This is object creation, and this is another object creation. Why? As name followed by two parentheses. This is a class code or an object creation, or as we referred to in the previous lab, this is just a syntax of composition, right? But there is a very important difference that I've talked about inside this. Let me just show you a model. Okay, so here in week 8 in the software engineering course, you're going to see that I've give you a guideline PDF for the UML relationship implementation, or association, composition, aggregation, and so on, right? And there is a video for this part also, right? This was from last year. This is not a new thing, but if you take a look at this file here, you'll see that I told you that this is composition, right? So let's take a look at how the composition syntax looks like, right? So this is composition here. You create an object and you store it in a permanent variable, meaning that in Python notation, you just attach this variable to a self object that is going to be existent in the lifetime of any object that is created of type class A, right? So This means that if this is a real kind of composition thing, then I would have said something like this. I would have something like dot create object, right? Right, and I would have returned the same thing. So this would be correct or logical composition, right? Since we are permanently, right, storing an object of B or A, right, inside a variable called create object that is permanently stored or attached to the self object, which means it's permanently stored to any object, in this case this one, right, that is created out of the factory type, and the factory object type. It would be actually looking slightly better if we created a constructor, and instead of having all of these cells all around the place, I can have just this initialized here, like self-created object, and we can just continue like this. So if this was the case, then we can say that this is composition, right? So this means that this is the composite, this is the parent, the whole, that creates parts of A and B. So in UML syntax, this would look like this. Instead of an association, we would actually choose a composition kind of thing, right? So let me just have this here, right? We can leave the association part here, but this would look like that, right? But if this was the implementation, this would mean that this is composition. But let me tell you something. Most of the time, whenever you implement simple pattern, simple factory pattern, or the factory method itself, you don't really use composition. We use something that is slightly weaker, right? And by slightly weaker, we refer to the dependency usage. There is a video that talks about this part, so I'm not going to talk too much about it, but the dependency is just a weak type of association, right? What if you need to use something? In this case, class J uses the class A, the class K, right? It uses an object of the class K. Why? Take a look. So J have a method that says use object, right? And it just needs the object K to take the first name, right, from object A, take the second name, concatenate them, put them in a variable, and return this variable. Now, a question, do you need to store object K to do that? In this case, maybe you don't, right? Maybe you don't need f name, first name or last name. Maybe this method is the only thing that is going to be using this object K's attributes, f name and l name. If this is the case, it would be totally valid to send the object to object K. So create an object of J, and beforehand, of course, create an object of K. Send this K object, which we stored in a variable called K, send it to use object method of J, right? So send the object here and send it to the method. The method needs these attributes from the object K. If the method is done, then our work is done. So in this case, we have a weaker type of association. This doesn't even qualify to be association because we did not permanently store object K in something called self.object_K equals object K. So this is not association, right? A weaker type of dependency looks like that. An object that is temporarily live within another object. So in the use case, in the use object method, right, within the time of calling the use object method, within this time, right, within this period of time, whenever you call the use object method from J, right, object K is going to be alive inside J, right, for this period of time. So the interpreter is going to execute this line, come to this method, execute this method, right? So object K is going to be live inside the J class for this period of time. Once the interpreter finished executing this line, and it got out here, right? We can say that object K is no longer stored in J. So we don't permanently store an object of K inside of J or an object of a certain class inside another class. We just need to use it. And this is the use stereotype. There is another stereotype for the dependency relationship, right? So for the dependency relationship, which is looking like a composition, but it's not really composition, it's something like this, right? Let me show you a better example, right? This is the example that is in the slide, right? You can check this part, right? So in this case, let me show you a better example. The stereotype for the equivalent or the weaker type of composition, right, is the dependency create, right? Dependency create relationship. So in this case, what if we are creating an object out of K, an object out of B, but we're not permanently storing it in a variable inside the factory, right? So this means that if it is permanently stored and if it is composition, so I can just easily come and say dict like that, and usually I would get, let me just redefine this one more time, then I would see a created object of type none. What if we created this, right? And then we said that we created an object out of A, right? And I want to see the factory object. You would see that the factory object contains an object out of K, right? An object out of K, an object out of A, I'm sorry, an object out of A that is permanently stored inside created object variable, right? So this is composition. So what if it's not composition? In this case, what if we wanted to implement it as a dependency create relationship, right, which is a weaker type of composition or association, right? In this case, you wouldn't store anything, and that was the previous implementation essentially, right? We don't really need to store A. I just want to create an object out of A, and this return is my lifesaver here, right? This return is what we need to enforce the dependency create, right? So if there's a return, you don't need to store anything within the object itself, so you don't really need the self here, right? So I'm not going to attach anything to the object, right? Create the this method is needed to create a certain object. This method inside this class on its entirety, it doesn't really need to store anything inside of it. It just needs to conditionally think, conditionally put some logic. Do I create an A object or do I create a B object based on the past type? If it is settled, which if statement is going to be ran which branch, then just return that object. This return is going to save you actually from the need to store anything within a class, right? So if you want to store things permanently, and this is creating an object inside a method inside another class, right? So creating an object from a different class inside a method inside another different class, this is essentially composition, right? And composition can be enforced to make sure that this is actually composition. The whole needs to have a reference of the part in all time. So this is the part, and this is the whole that is creating it, the factory object class, right? So the whole needs to reach out to the part in any time that it wants, right? So meaning that if I inspect the whole, right, I should have an object of the part inside of it anytime of the program, right? And this is why we have the self here, right? We store this part, whatever the part type is based on the conditional here, we're going to store the part in this variable, right? So we don't really need the return in this case, right? We don't really need this line, right? This is just enough for me, right? But if this was implemented via composition, and this is really not common, just to let you in the picture, that's really not common, especially in case of creational design pattern. And just to let you understand what we are doing, we're discussing creational design patterns, and one of the creational design patterns is a simple factory and the factory method design pattern. So continuing, this is not really common, right? Using composition between factory objects and products or concrete products, right? This is the common thing, which is using the dependency relationship, especially the create type, meaning that we're not permanently storing the part inside the whole. We don't really have a whole and a part here. It's not composition, right? This is just a class that is dependent on some products, right? It depends on some other classes, right? And once this method inside this class finishes the conditional creation, we're just going to return the created object, and that's it. We're not permanently storing anything. And in fact, to make sure that actually this is true, if you inspected this, so create the object, pass the conditional parameter, and based on that create the object, and inspect the factory object, you wouldn't see that it contains anything, because there is nothing attached to self in anywhere here, right? And that's the point of design patterns. We need to use them. We need to use them to create something, to delegate something, right? But it's not usually, it's not going to be having most of them, it's not going to have like associations or compositions. Most of the time, either it's association as relationship types, right, or dependency relationship, right? It can be either use, it can be create in this case, because obviously I'm creating an object, but it's not composition because I'm not storing this object permanently inside a variable inside this class, right, inside the factory class or the factory object class. Then this is the time for the create stereotype to take place, right? So how this is denoted here in the class diagram, so I'm just going to say that it looks like this, right? It looks like this, an arrow like that, something like this, right? You can find it in Visual Paradigm as well, right? But what really matters is that you need to have this dashed, and you need to write the stereotype of create, right? And this is essentially the factory, the class diagram of the factory object pattern, right? Don't care about these kind of attributes and operations. This is just a boilerplate by the platform that I'm using. So let us go to the main use case. So my main use case here is the following. Actually, what we have done so far is a data access class that is operating on, let me just have a note here. This is operating on a storage of JSON type, right? This is my data storage. What if we decided to have another data access, right, that works on all tables? This is a data access that works on all JSON files. So what if I have a different kind of storage, right? What if I have the company decided at some time that we want to work on MySQL, or let's say the company decided at some point to work on Postgres, right? Or maybe Firebase or MongoDB, right? Or SQLite or whatever, right? So what if we change the storage, right? This means that the logic written within these CRUD operations in this data access class is going to be dependent on the storage that we are going to fetch the files from, or to fetch the data from, or to insert the data into, right? So the CRUD is going to be modifying the storage, right? If you change the storage, the CRUD definitions are going to be changed, right? These functions or methods, right? So in this case, I need to have a single CRUD or a data access file, a data access object for each kind of storage out of these, right? So what in this case, how can we handle this, right? The use case that we are talking about essentially is the use case is multiple database support system, right? This is not the full implementation of the use case. I'm just going to show you a partial part to get you started with design pattern and to have only at least one design pattern implemented in your project, and all of you can do that, right? So the complete use case is going to be uploaded later on, right? I'm not going to upload so many materials down because I know the time is tight, so I'm just going to show you how to implement the simple factory. But the real implementation of the use case, you would need the factory method plus another design pattern called the DAO design pattern, right? Or the data access object design pattern, right? So what if this is the case? What if we have another case that talks about what if we have a certain data access that works on maybe SQLite, but the CRUD operations are maintained via an ORM called SQL Alchemy, right? Or maybe your data access is maintained via another ORM, which is the Django related, which is essentially Django models, right? And behind the scenes there is Postgres, right? There is Postgres, and here behind the scenes for SQL Alchemy, maybe there is MySQL, right? So what is the case here? How do we implement this kind of conditional creation, right? What we really should take as a note here is that all of these are subjected to conditional creation. So essentially behind the scenes there is somewhere in the code, I don't know where yet, but somewhere there's gonna be an if statement and then another elif and another elif. So if the data storage chosen by whoever is going to be designing a certain part in the application, right, if the storage or the format chosen to be JSON, then we're going to create a data access for JSON, right? If the storage is chosen to be MySQL, then we're going to create a data access or CRUD class for MySQL. If we chose the storage to be Postgres, then there's going to be a CRUD class that is going to be created based on Postgres, right? So these are multiple if statements, and if we have multiple if statements, and inside each if statement, we would have some kind of conditional creation, just like that in this if statement, based on a past parameter, right? We're going to create a certain kind of product or a certain kind of object. In this case, the factory is the perfect fit for our creational pattern, right? So what kind of factory is it a simple one? Is it a factory method, or is it an abstract factory? But you didn't really take the abstract factory in the lab, or I don't think it was discussed with you, so I'm not going to talk about it at all. By the end of my solution, I'm going to show you in a class diagram design only how to implement the factory method and how is it different from the simple factory. So in our case, I'm going to stick with my simple factory. This is my get started kind of design pattern or factory design pattern. So I'm going to start with the simple factory object, right? Later on, I'm going to show you the difference and how to refactor into a factory method design pattern, right? So I'm going to, for this use case, to go with just adding a MySQL data storage, right, and a MySQL data base, right, and I'm going to create a data access that operates in this MySQL. And for the current data access which operates in JSON, I'm just going to rename it into JSON data access, right, and this is going to be renamed into MySQL data access, right. Some differences are going to be happening here. I don't know, still I don't know what is going to be there in my variable, right, in my variable section, okay, in the constructor, but I know that's going to be read, write and delete and update, right? Maybe find all, maybe we're just going to have find by or find first match and find all matches. And I'm not going to implement delete, and instead of update and write, I'm just going to replace them with something called do query, right? And it essentially takes a query of type string and it returns you know, a list, right? It can return a list, it can return multiple things. So I'm just going to leave this part empty, right? So maybe the query is an insertion, right? So if it's an insertion like an update or delete, in this case, I don't think it's going to be returning any queries, right? So this is going to be void, right? So this is just to represent insert and update in just one method. You're going to understand it in just a second. Now the question is, how do we connect this to our entity classes? So it's account and blog in their constructor definition, they need a data access. This needs a data access operating on the user.json, and this needs a data access operating on the blogs.json. So let me just remind you of this, what it looks like. So this is how things looked like in the previous implementation. The account needs a data access object, and immediately whenever it takes it, it just runs a read to grab all of the users, right, or the accounts from the, if you go to the database layer, right, this folder, you will see that this is the user.json. It has a column of username and password. So it grabs all of these dictionaries, right, into a list and store them in temporary users list, right? If you take a look at the other entity, which is the blog, same thing. It needs a data access object, right? And here it just needs another account object because, you know, we have a one-to-many relationship. An account can create multiple blogs, right? One to many. You see the star, right? So this means that from the one, it's going to be it's like, as we discussed in the previous session, it's like foreign keys in database. So from the one, you're going to have a reference from the one in the many side. So a reference from the one, meaning that this association means that there's an account object. It's stored inside a variable, right, permanently inside the blog account, or inside the blog class, right? So this is just for that. Maybe you need, for certain blogs to be able to create blogs, you need to check that someone is logged in, and this is going to be found in the account object. Another thing, maybe you need the username, and this is going to be found in the account object. So regardless of this, blog needs a data access object, and once it takes it, it just fires a read, right? It just fires the read function or the read method to grab all of the blogs from the blogs table or the blogs JSON file, right? Which is a list of dictionaries that has these three columns: title, body, and author. Okay, so the question, how is this going to be implemented? Are we going to, seriously, are we going to connect like a line from each entity, right? So a line from each entity to the new data access that is going to be created, right? Like that, a line from this entity to the other data access that is created. I don't think that this is practical, right? And this is obviously not the thing that we are going to do, but instead, I don't know if you guessed it or not, but these two accounts, or any entity, the account and the blog, any entity class essentially is going to be communicating with a factory method, right? This is the actually the solution here. It's going to be communicated with a single point of contact, which is the factory object class, or the factory object pattern here, right? So it's going to be talking to this class, and this class is going to be either creating a JSON right? It's either going to be creating a JSON data access class or that JSON data access object, or it's going to be creating a MySQL data access object. Okay, so let's take this step by step. First of all, I'm just going to disconnect these kind of relationships, right? And I'm not going to need that anymore. So I'm just going to, this is the data access layer, by the way. So I'm going to refine my implementation, my definitions for these two classes. Okay, so in this case, I'm going to use MySQL, right, as the other data storage. You can use anything. This is just for illustration purposes, right? You don't really need to have MySQL. You don't need to implement MySQL. And if you have any kind of implementation, I think by now, this is by the end of the semester, so I think by now most of you have a clear data access class implemented, or at least they have a clear vision of the data storage, right? So if you're from the start of the semester you're using Firebase, then consider Firebase to be your default. And just if you want to follow the exact use case that I'm following here, and just add an extra data storage for you, right? Maybe it can be MySQL, Postgres, whatever, right? So I'm going to use MySQL. So let me just show you what the client means. So we need to talk about something called clients, or database clients, or drivers. Now, clients or drivers are the methods that we use, or the libraries, right? Just say libraries, right, offered by database engines, right? So some database engine like MySQL or Postgres or Oracle, it's going to offer you a library in the backend language that you are working on. So if your backend language is Python, if you go to the official documentation of the database engine, if you go to the official documentation of MySQL, for example, you would see that it is offering drivers and clients, libraries, right, or frameworks to allow you to communicate and modify the MySQL databases, right? So based on the back-end programming language, of course. So if your back-end programming language is Python, then it's going to offer you a library in Python that allows you to modify database created in MySQL, right? Same thing. If your back-end, for example, is PHP and you're using, for example, MySQL is going to offer you a client or a library or a driver that allows you to modify any database, any MySQL database from PHP. Right, using PHP syntax or by writing some PHP code, right? So depending on the backend programming language, you would see an offered client, right, for the database engine that you want to communicate with in your database layer, right? So if you go to the official documentation of MySQL, right, you would search. Actually, you can try this out. You can say MySQL driver or client Python. The first thing that you're going to see, I think, from the official documentation is this one, is the Python connector. You can have multiple clients. The client for a MySQL database or a MySQL engine doesn't have to be offered by the official documentation itself. You can find other libraries. Like, for example, MySQL client is a library that is using Python, right? That uses Python to interface into MySQL, right? Like this client is your gateway to the database, okay? Based on the input, of course, to the gateway or the input to the interface is dependent on the backend language. If you're using Python in the backend, then you would use this to enter or to gateway into the MySQL world or the MySQL database engine, right? And you can have multiple libraries that does that. So there's multiple things. So if you open up the official documentation of the database engine MySQL, you can go to installation and you would see that they are using or they are offering you a library that you need to install. I don't know where is the installation actually. Let me just take a look here. This one. So pip install MySQL connector. It's called MySQL connector. This is the library or the client offered to Python by MySQL database engine, right? There is other unofficial clients, right? For example, if you're using Flask, it's unnecessary to follow this, of course. If you're using Flask or Django or any kind of backend framework, you can use whatever MySQL, if the case is MySQL here, of course, as database engine, right? Or storage. You can use whatever kind of client that you want. But for MySQL, for Flask and MySQL, they offered you from the Flask documentation something easy that you can use, something called Flask MySQL, and this is the library or the client that you need to install, right? There is another client for MySQL that is called PyMySQL, right, that you can install, which allows you to interface into database, a MySQL database, and write using syntax, Python syntax. It allows you to write in Python syntax some queries that modifies MySQL database, right? And there's by MySQL, right? There is the connector, MySQL connector. There is the Flask MySQL in case you're using Flask in the back end. It's not a must to use this if you're using Flask. You can use anything else actually. Any client that allows you to access MySQL database server is totally fine. There is another one called MySQL client, right, which allows you to interface into my MySQL server, database server, right? So I'm going to use the one in the official documentation of MySQL offered to Python, right? So I'm just going to go to the examples. So this is the first example that we are starting off with. So I'm just going to go back to my source code and I'm just going to create a test MySQL. This is not the data access class. I'm just going to test some stuff. I'm going to open up the terminal session here, and I need to install this, right? I think there was a venv somewhere. Let me try to run this to activate the venv. Right, so let me just activate. Okay, wait, just try to do this. It refuses to activate, but it's okay. So you can just say source venv script activate, and we're good to go. Then I'm going to install MySQL connector. I'm doing all of this to set up, right? To set up the ground to use the simple factory design pattern. Pip install. I think I did something wrong here. Maybe I have this. Let me just see the installation one more time. Okay, so we need Python. Alright, so obviously I have this installed, so all good. Alright, so let's go back to this part and let's see the example here, and let's take this example from there. Right, so let's import this MySQL.connector, and this is the client. Again, this is the client, or what we call a driver, a Python driver a Python MySQL driver, right? To allow you to write Python syntax just like this to access a MySQL-based database. Now I have a database created here. I have my MySQL server actually up and running, right? And I created a database called SimpleBlog, right? I'm using this SimpleBlog database. I created two tables, a users table and a blogs table, which is essentially equivalent to the blogs.json and user.json. And since this has a username and password, I created the users to have a username and password with a primary key auto-implemented ID variable. For the blogs, it's essentially also the same thing: title, body, and author. Title, body, and author. We have the primary key as the ID of the blog, and of course this is a one-to-many relationship, so we need to place the primary key from the users as a foreign key into the many side, which is the blogs, right? So I'm just saying that this is the author is going to be referencing the it's going to be a foreign key referencing the primary key of the username, right? Username, right? From users. Note that foreign key needs to reference something unique. This is why username I decided to have it as unique. Otherwise, I would have just the ID from blog to reference the user ID from user, but I just need to be consistent to what we have been doing inside the labs. So the author here in the JSON thing here, we decided to have not an ID, but just a string of the username of whatever account is associated with it. Right, so this is what we did in the class diagram on the back end. So I'm just going to stick to the same thing in my database physical implementation or schemas. Right, so this is what currently the users have. I only have one user, and I have this user, right, creating two blocks. Right, this is the title and this is the body, and this is all. So I'm just going to modify the configurations of this connection. Now, these are my credentials for the database. This can be like this, or it can be localhost. Both of them would work. And the database name, of course, is going to be the one that I've created here. So it's going to be like this. You can actually add multiple stuff like port, right? But the port here by default is 3306. I'm just going to leave it as it is, right? I'm just going to name this as connection. And let's try to run this. So it didn't throw any errors, so the connection most likely has worked out. So I'm just going to create, this is the connection. Usually this is the one that handles the connection object is being fired from a connect method on this client. So this is handling every thing related to connecting to your database based on these parameters, user and password and host and database name. So we need something to let us create or execute queries. To execute queries, we need something called the cursor. So I'm just going to create a cursor, and this is in most in most MySQL clients or in most database clients in any language, essentially in any backend language, you would see something called a connection object and a cursor that lets you execute queries on it, right? So if I know that this is the cursor, I can just say execute, and I can write some insertion here. I'm just going to make this really quickly. So insert into users, for example. Under username and password, I'm going to say these values. You can skip this part and just go to the simple factory implementation. I'm going to have some kind of a timer that lets you fast forward through this, because this setup is not really necessary. I'm just letting you know what the code is going to be doing and what it's going to look like. So the values are going to be something like Magid, and the password is going to be something like this, and we can have a semicolon by the end, right? And since this is an insertion, you need to commit the insertion. You need to make sure that it is persistent, right? And it's reflected in the database. So you would need to do something called connection dot commit, right? Once you're done, I'm just going to first of all close the cursor and then close the connection. Now let's try this. Duplicate entry. Maybe we did this twice. So let me just go here. Yes, we have run this previously. So I'm just going to, but the insertion is actually working. So I'm just going to try Mahmoud. Let us run this and just check from here. So everything is good. Now instead of going back to my database server and to the backend code, I just want to see what I have inserted. So I'm just going to create another query, which is going to be select everything from users, right? And this is essentially the query, right? So I'm just going to comment this part out and run this, and I think we need cursor dot fetch all, and this is essentially the results, right? And this is going to be returned as a list of, by default it's going to return a list of tuples, right? So this is the first record as a tuple, and this is another record as a tuple, and so on. Tuples are annoying because if you have the tuple, this is at index of 0 and this is an index of 2. So if you want to access this, you would need multi-dimensional array. So at index of 0 you get this, at the index of 0, 0 you get the ID, and index of 0, 1 you get the username. So in order to change this to a list of dictionaries, and this is actually what maps to our list of dictionaries here to the JSON file, right? And don't forget also in the data access, right, we define something like find by and find all, and all of these require you to have a list of dictionaries, right, a key value. So this list of dictionary, this is a dictionary. Since I know that this is a dictionary, every element is a dictionary, then I can safely assume that in this dictionary, right, in this dictionary, I can just say from this row, from this dictionary, access whatever kind of column that I know that is existent in this dictionary, in this row. So this can be the dictionary, this can be the title, the author, the body, and so on, right? So to be kind of normalizing everything, right, I need to have this to be returning list of dictionaries. So we can just modify this and add something called dictionary true, right? And if we try to run this, now it's going to return to a list of dictionaries. So this is the first row as a dictionary, right? This is the second row, and this is the third row. Now the find by and find all are not going to complain whenever we implement the same exact, have the same exact definitions in my data access, but for the MySQL part. Okay. So this is essentially the part here. I'm just going to comment this out. I'm not going to run this things anymore, right? Okay, so let's modify the code before doing the MySQL data access. Let's rename this to JSON data access, and I think the rename is quite enough, right? So if we go to the entities, we don't really create a JSON object here, so there is no composition. This is the beauty of using dependency injection here, right? By using association or dependency injection, essentially the same thing, associating the object, right, into a variable, right? But at my client, right, at the main client, which is the app.py, which essentially is going to be the same file that runs up or starts up or fires up your backend server, Flask or Django or whatever. So in this part, I'm just going to say here and here, we just need to say JSON, and this needs to be modified in the import as well, right? And we need to say that this is going to be the name of the file follows the name of the class, right? So everything is settled. If you try to run this, hopefully nothing breaks. Unexpected indent. Did we indent anything? Okay, let's try again. It's some annoying bug in my Visual Studio Code, but anyways, so everything works as expected. Actually now I'm actually logging in, but using the storage of the user's JSON, right? So I just use this user to log in, right? But anyways, right, let's now implement my MySQL data access. So I'm just going to say that inside data access layer, these are the entities, right? I don't care about the entities now, right? The data access layer is just going to have MySQL data access, the py, and of course we forgot an s, right? So this is going to be looking like this. This is the class. I don't know what is going to be inside of it yet, but I'm just going to keep this here. And I'm going to try to imitate JSON data access as much as possible. So I'm just going to take everything from JSON data access, right? And we're going to see how things are going to look like. I just said that instead of write, I'm just going to do something different, and I'm going to implement something called do query, right? What does do query have? No idea. We're just going to see it together, right? And find by and find all should be essentially the same, right? Same thing for read by or read. I don't know what's going to be inside read, but anyways, right? And same thing for prepare connection. Prepare connection needed a kind of a file name. So let's see what this looks like whenever we say that this is a MySQL implementation of the CRUD, right? So let's take what we did here, right? So this is my client, right? This is my driver for MySQL. I'm just going to put this comment above, and I'm going to say that because this is slightly long for me, so I'm just going to use an alias and use connector here. And instead of this part, I'm just going to use, actually I can just remove this part, connector, and things should be working the same, right? So what can we do is that prepare connection should be responsible for connect, right? So what I'm going to do is the following. I'm going to take this code, right? And I'm going to say that prepare connection is going to have this part here, right? All right, so I think you're expecting me to do the following now. Since this connector is undefined, you can see the underline here, maybe you are considering that I should take the import or the client. Sorry about that. To take the client or the import and put it in this class, so it's going to be defined here, right? Now, let me tell you that this is not what I'm going to do for one simple reason. See, most of the clients that is offered by database storage or database engines, right, whether it's offered from the official documentation of the database engine itself or offered by a third party, someone else, maybe the community of the backend language, the community in Python in this case, created something that is unofficial, right? Right, something like PyMySQL or Flask MySQL, dependent on the certain web framework on Python, or MySQL client, right? Right, anything that Python that is not related to MySQL connector, which is essentially the official client or driver given to you by the MySQL documentation, right, for Python backend users, right? So if you searched online, you would see that most of these connectors, most of these clients or drivers usually have a connect method, right? And this connect method takes most probably these same 4 parameters. Not in order, of course, but this is just keyword for arguments, right? So it takes user, password, host, and database name. Let me show you an example. If you go to PyMySQL and you check the documentation, this is the installation. If you see how this is being used, you would see that it's essentially the same thing. You import PyMySQL, which is a different client, right? But it allows you to interface from Python into MySQL database server, right? It has a method that is called connect. It takes host, username, password, right, database name, and a couple of other things, right? But these are the most important configuration parameters. If you go to Flask MySQL, it's the same thing, right? It uses host and port and user and password database name, right? If you go to MySQL client, you would see that it is actually also the same. Let me just go to the documentation real quick and show you the maybe you can find it here. So you import the same thing, the same stuff, right? If you're using MySQL client, which is a different library, okay, you have a connect method that takes localhost, the host, right, the user, the password, the database name. So essentially all of these clients, right, they offer you a connect method which have most probably all of the same parameters passed to it, right? And even if you're actually using a SQLite, same thing for SQLite, you have a connect method, but actually in SQLite, I think you just need to pass the database name. But actually you can have, I think so, you can have a keyword argument database, right, and pass the database, right? But essentially everything is the same, right? So if this is the case, I can safely assume that all of these are going to be found in any client that I'm going to be using the .connect method on it, right? So in this case, I'm going, instead of passing a file name, I'm just going to say pass the driver, right? So if I know the driver, right, then we can safely assume that this driver, any client that is going to be used, MySQL connector, by MySQL client, SQLite, all of these drivers are just going to have the same connect method, right? Okay. Something better to do than this, since we do have a constructor here inside a class, since this is a class. So let's just make use of this constructor, and instead of passing the file name, right, I'm just going to say that this driver is going to be passed via the constructor. And since I have the driver passed, I'm going to permanently store it inside a variable called driver and attached to the self object, or the object is going to be created out of this class, right? So from the driver object, which is permanently stored inside self, I can just say .connect, and all of these are going to be the same. Now, one change would be, one would say, why do you have fixed values? These are hard-coded, so we need to make these dynamic as much as possible. So instead of having these here, I'm going to say, since the connect inside the prepare connection, right, the prepare connection, the connect needs all of these parameters. So I'm just going to prepare them from the signature of the prepare connection method, right? So I'm just going to take all of these, and I'm going to say that these are the passed parameters, right? This is the method, this is the passed parameters to the method signature, which is going to be used by the connect method inside any driver passed, which is MySQL connector, PyMySQL, whatever, right? So let's place these like this from the signature. Whatever parameters that we are injecting, I'm just placing them respectively. the database name, right? And essentially this is it. We can actually make this slightly better to format it like this, so you would not get confused. All right, that's one thing. Now you know the connection, or the did connect returns a connection, right? So I'm just going to store this inside a permanent variable. Actually, I'm going to need another one for the cursor, since we can create the cursor out of the connection. So I'm going to just do this in one line. Like that, right? But this is self dot like this. Now I'm going to store the connection in self dot connection. Now once we have the connection inside the cursor variable, I'm just going to create out of the connection that I've created the same thing that I've done here, right? So exactly the same thing, right? With the dictionary to be true. Okay, so this is good. Now we can test that this works, right? So I'm going to write some line code and create an object out of my SQL data access and pass to it the needed client. So I'm just going to need import in this case and pass the connector, and we need to prepare the connection then, right? So after we create MySQL data access object, I'm just going to take this form and call prepare connection with all of the good stuff that we had from before. And let's see if this works or throws an error. So obviously it works, nothing was thrown. This is good. Now let's implement the do query, right? So the do query here is going to be essentially just using the execute from the cursor, right? So from the cursor, I'm just going to need the execute method, and I'm going to be passing a query which is going to be entered as a string here. So once we have the query, just execute it. This is it, right? But the question is, what if we have different types of queries? What if we have a query that inserts or updates, right? Or maybe deletes, meaning that the query doesn't have a return value. So I'm just going to have a default parameter called return value. And if you need to do any insert or update or delete, meaning that it is not a select, then leave the default parameter or the return value as false, right? Right. But if this was not the case, maybe you need to have a select statement, right, to do a query that does a selection, so it returns something, it fetches something. In this case, we would say, of course, there are better options to do this, right? You can have a query that insert, you can have a query that deletes. I'm just trying to do something generic that gathers everything up, right? So if return value is true, then we can just say from the cursor, fetch all, right? And we can just return whatever values is going to be returned, right? I'm not going to go into, you know, crazy dimensions here, but if you have, for example, if you want to fetch just a single value, right? So you can have another, maybe you have another default argument that says, for example, single is false, right? So let's say that you have a return value, so this is going to be set into true, right? If it's a single value, right, then set this into false, right? If this is a return value, right, but in this case, but have another if statement nested inside of it, but the single is false, not single, so return use fetch all, right? Elif, if single is true, then instead you can use fetch one, right, to just fetch the only one record, right, based on the where clause that is going to be existing at the query, right? But I'm not going to go through this path, so I'm just going to keep it simple, just like that, right? So let me try to do a query. Okay, so from MySQL DAO object, okay, I'm just going to, or data access object, I'm just going to say the do query. I'm going to pass the same insert query. and I'm going to leave the return value to be false because I don't really need to return anything here. I'm just going to say Mahmoud 3, and let's see what this is going to look like. Okay, I don't know if this worked or not, but let's check. So that's not Mahmoud 3, this is Mahmoud 3. Okay, so obviously it did not work, and I think you know the reason, because you need to have connection.commit. You need to persist the insertion into the table every time that you perform any insertion based query. Okay, so I can do this easily here, right? Self.connection.commit. Or another thing that we can actually think about is that if you searched slightly online for maybe 5 minutes or something, you would see that most of these clients either within the connection object, which is this part, or within the cursor object, which is within this part, either one of them, it's going to accept a parameter that allows you to auto commit, right? Maybe this is not a very safe thing to do, but I'm just going to, I want to reduce the lines that I'm writing as much as possible. So there is a parameter that we can add that is called auto commit, and I'm going to set this as true. In this case, I don't really need to commit anything, right? We don't really need to say connection.commit. We can try this file, but I'm just going to go and do it here immediately. We can actually test this file first. Let's say that we want to insert Mahmoud 10, right, without connection.commit and using this parameter auto commit equals to true, right? So let's try to run this. Connector is not found. Did we take away the import? Yes, I think we cut the import. Okay, so let's run this, and you can see that Mahmoud 10 was inserted because this is the selected or the fetched rows, right? So it was inserted like that, right? So let's modify the same thing in our class, right? So now if I go to the class, let me just say that this is Mahmoud, for example, 100. Okay, so let us modify this. Now in the connect, I'm just going to do the same thing. I'm going to add this parameter. Okay, but instead of having it to be true, just following the same pattern here, I'm just going to take the value from the signature, right? So take it from the signature and put it inside this keyword argument. Okay, now one would say that actually this is not clean, and I would actually agree with you, because this code, even if it's slightly clean, we can say that this code for sure is non-robust, right? Meaning that, see, whenever we modify somewhere, you modify the connect. You say that the connect now takes a new argument, right? And then you need to modify this same. For this modification, there's another of retrospective modifications that needs to be taking place, right? So this modification, the first one, after adding a parameter inside the connect, this is an internal dependency inside prepare connection, right? And this is tight coupling, by the way. This is tight coupling, which is not a very good thing, but I'm going to leave it for your imagination in order to see how can we refactor this to a slightly better version, right? So if you modified this part, you would need to modify the signature of the calling function or the calling class. This is the client. Prepare connection is the client or the calling function that calls the supplier, which calls the connect method from the client or the connection object, right? So this is a non-robust code because it easily breaks if you didn't make all of the needed retrospective modifications, right? So how can we solve this? Right, there are many ways to solve this in Python. Generally, if you want to solve this issue, even if you modified internally inside a function, you don't want to keep modifying the signature of all of the calling functions, right? You don't want to have this. So to do that, you can follow something called the DTO pattern or the data transfer object pattern, right? I'm not going to talk about it. Instead, I'm going to give you a slightly Python-oriented solution, which is called the quarks, right? You're going to see the quarks in just a second, but just we want to test that this is working. So I'm going to run this. See, this is the auto commit, and this is the auto commit. So I'm just going to add the parameter here as well, and I'm going to add it as true. My prepare connection. This is my client. Okay. Now let's try to run this. And there's an invalid syntax where symbol. Did we forget? Yes, we forgot a comma here. Okay, so let's take a look. we added Mahmoud 100, so everything is good. Now, the final thing is to modify this kind of error that we have seen, right? The signature. Or let me just do one thing first. You see that this is happening in 2 steps, right? This is happening in 2 steps. So you can see that we need to create an object of data access and we need to prepare the connection. That wasn't really the case if you take a look at the JSON data access. So in JSON data access, let me just bring this here because we don't really need the part on the left anymore. In the JSON data access, right, the first data access class that we have created previously, we saw a slightly different pattern. We saw that the prepare connection is being called, right, within the constructor. So immediately, if you take a look at the entity, any entity, let me just go to any entity here. Take a look at any entity. So the second that you pass a data access object, right, you would, first of all, you would call a read method on it, right? So we just say .read. Right? If this data access object is created for the users.json, then you would just say .read. If this data access object was created for, right, created for the blogs.json, you would say .read. And if you don't remember, in the app.py, in the main client, this is where we supply the type of JSON file or the JSON table, whatever you want to call it, right, that we want to operate on, or that we want our CRUD methods inside this data access class to be operating on, right? So I'm going to follow the same pattern. First of all, I need a .read because I don't really need to have, I don't want to make drastic changes to my entire code base. So I'm going to leave the .read as it is, right? But I need to have a read in my MySQL data access, right, as well. So I'm just going to say that this read is going to be calling the do query, right? And usually it's going to be just, since it's a read thing, right? So it's going to be selecting everything from users. Now there's a slight problem with this implementation. Of course, this is going to be having a return, right? The first problem is that this query is operating on what? It's operating on the users table, and that's essentially wrong because this data access, MySQL data access or JSON data access, it needs to be what? It needs to be generic. It needs to be working on as much table as possible. Now, this is not the best design at all because every concern, right, in separation of concerns principle, every concern should be handled respectively on its own, right? So here, if you take a look in JSON, we send the file name via prepare connection, which is equivalent to the table name that you're working on, right? So in this case, this is wrong. So problem, right? Data access is not to be tied with a single table, right? So to modify this, we have 2 solutions. The one that we are going to do is not the best, but we can have a path table name to the constructor that we can put here instead of this kind of hard-coded users to table. Maybe you have blogs at table, right? Since we have 2 tables here, we can have more, right? So we can add this or pass this to the constructor, right? This is one thing. The other solution, which is a slightly better and recommended, is following the DAO pattern, right? I'm not going to talk about the DAO pattern. I'm just going to mention it briefly whenever we finish the first use case of the symbol factory, right? But essentially, the DAO pattern means that you have a defined data class for each entity or table in database, right? So this means, just to let you understand what I'm saying, this means if I have a user table, then I have a user DAO class. If I have a blog table, then I have a blog DAO class. If I have an expense table, then I have an expense DAO class, and so on. So it's not a single data access class, regardless of the storage that we are implementing the CRUD operations based on. This storage can be handled differently via interfaces or abstract classes or whatever. So we're talking about here to create a specific data access for each table, right? So this is the DAO. I'm not going to do the DAO here. I'm not just going to stick with the first solution. So here I'm just going to add to the driver a table name, right? And this table name is going to be stored permanently, right? And instead of users here, I'm just going to say that this is going to be an f string, and I'm just going to say table name, just like that, right? So this is the first thing. We finished the read because I know that most of entities, since once they have the injected data access object to them, right, they will just immediately in the constructor of each entity, whenever the entity is created, right, in the main client, right, in app.py, for example, they will call a method called the treat. So we prepared the treat. That's it. Now, the other thing that is missing is that we need to make sure, just like the JSON, right? So inside JSON, you prepare the connection, right? So you access the file immediately. We want to access the database immediately, right? And create the connection in the cursor. So here, you access the file immediately, right? So we need to have the same thing. We don't really need to bother about preparing the connection inside whoever client is going to be using our data access class, right? We don't want to go after this and say something like self data access user and prepare connection, right? So we want to reduce the abstractions. If you remember our talk about abstraction, right? We want to we want to increase the abstraction, right? Here there is no abstraction, okay? Because everything is exposed to the client. This part is the client, so I'm using the MySQL, and then I'm preparing the connection, and so on. So we can just increase the abstraction by letting this part live inside the constructor. So the second that I create an object out of MySQL data access, I'm just going to call internally the prepare connection. So this is how we can increase the abstraction, right? Of course, it's going to add. There's going to be a trade-off here. The first trade-off is that first we increased the coupling, right? Because now I'm just going to do the following. I'm just going to call prepare connection inside constructor. So there is coupling here, right? The other thing, which is, of course, this is the bad here. You need to understand the good and the bad of your design. We increased the abstraction. You know what I want to say, right? And this is good, right? So let's see what this looks like. I'm just going to remove all of these comments. So here, I'm just going to say self.prepare connection. Now the problem, which is the one that we have mentioned, right? Because this is non-robust, and our other case, which is maybe this is problem 1 and this is problem 2, which I think it has been solved via the table name thing, right? But not using the DAO. So problem 1 is that the code is not robust, right? And the solution to this, as we discussed, the not so good, or the Pythonic, I'm not going to say not as a bad solution, but this is something that you can do, I think, and not in all languages, right? The better solution, and this is the most universal one, right, is using a DAO or a DTO, or the data transfer object. Right, so I'm just going to follow the solution, right? So let us see what this is going to cause, what kind of problems this is going to cause, right? So I'm just going to close all of these and have just a single one here. So whenever I place prepare connection here, you know that prepare connection takes all of these values. Now we can continue doing what we do. So we can do this. See, if we didn't do this, the code is going to break, right? And it's going to be a non-robust code, right? And actually, we're violating a principle from Solid, but I just don't want to talk about it because I want this session, that was the purpose of the session, to be as quick as possible. We're violating from Solid a principle called open and closed, right? The open close principle means that means that your code should be open for extensions but closed for modifications, right? In this case, every time that we modify something, it's not closed for modification, right? So we extend something, right? We enhance a feature, we add something to a certain class. But you would see that adding a certain feature, for example, here, right, needs for you to modify more and more in the calling class or in the client class or the client method or the calling method, which violates the open close principle, right? But anyways, we didn't really take this inside the lab, so I don't want to emphasize on it, but this is just a non-robust code, because if we didn't modify, if we called prepare connection here, and I know that prepare connection takes all of these, right? So if I did not put all of these inside my constructor, it's just going to throw an error to you, right? First of all, it's going to break because we can't actually run this. It's going to crash, telling you that these are undefined. Where do we get these values from? So you would need to pass them to the constructor like that, right? And to me personally, this is not something that I would want to do, right? And instead, let me just show you a run sample. Let's see how this is going to look like first, right? So you know that a prepare connection actually should be returning what? Be returning self connection and cursor, right? So we can modify this implementation slightly, okay? So we can say that prepare connection is going to return an object. I'm not going to store it permanently now. I'm going to keep these, but just bear with me. So this connection object that's created, I'm going to create a cursor out of it. And this is the cursor. Now I'm going to say that both of these values are going to be returned, right? And I know that now this returns two things, right? So I'm just going to place it here, right? So respectively, this is going to be returning the first thing, connection is going to be placed here, and the cursor is going to be placed here, and everything should be the same, right? Now let's see how this looks like. Now instead of using prepare connection after creating the object, the second that I create the object, I just can pass these parameters just immediately like that. I wouldn't need the prepare connection anymore. Now let's try to run this. I think it's going to tell me that I need a table name here, right? So we need the table name, right? So let me just say that we are operating on users table, and let's do Mahmoud 200. All right, and if we check the database, we would see Mahmoud 200. So everything is working. Tamam? That's good. But what's not good is that the continuous modification, the endless open modification loop, right? So instead of doing all of this, we can actually place something that is, instead of all of this, I'm just going to show you something called the works or the keyword arguments. The keywords or the keyword arguments are essentially the same thing as this, right? But passed into as an object. It's passed as a dictionary to the function. And these two stars are just going to unpack them. It's just going to demystify them. It's just going to unpack them, right? So this is equivalent. Let me just show you this like this, right? So this is equivalent to this. It doesn't have to be quarks, by the way. It can be any name, but it needs to be preceded with two asterisks. This is a Pythonic solution, right? So this is equivalent to all of this part, right? So after driver and table name, we have user, starting user to auto commit. This is equivalent to all of this part. What is going to happen is that we're going to pass these quarks, right, into my prepare connection, like this, right? So what happens inside prepare connection is what matters, right? So I'm just going to change the definition so it accepts keyword arguments multiple. This actually means multiple, right? So it means multiple. The first star means multiple keyword arguments, right? So multiple or unlimited keyword arguments, right? And the second star, I think it refers to unpacking, so, right? So we can unpack everything, right? So if I pass these as an object, so this is equivalent to passing everything like this, right, as a dictionary, for example, and we're going to see this dictionary, right? Maybe this dictionary is going to have a value of any value. I don't care about the value here. I'm just giving you an example of what the quarks is doing, right? So this dictionary is going to be unpacked, right, via these two asterisks. So what's going to happen is that the connect is going to check this dictionary, which is starting after the table name, whatever is passed after the table name, right? And if it has a user, it's going to unpack it to user, the keyword equals the argument, right? And it's going to unpack it هتفكها يعني بالعربي يعني تمام. It's if there is a password and a value, so it's going to unpack it into password keyword and its value, and the host keyword and its value, right? So it's just going to unpack everything, right? This is what it means to have the works argument. Okay. Okay, so this, how the definition is going to look like. Notice that in the client, whenever I use the constructor of this class, right, you can pass whatever you want. If you have other, if you have any other parameters that you want to pass, right, maybe something related to the port number to be 330, for example 8. If you need to change the port for any reason, you can do that. You can keep on modifying and adding, right after the table name here, starting this, exactly starting user. So you can keep on adding multiple parameters as much as you want to the connect method, right? And no one is going to tell you anything is wrong, right? So you wouldn't need to go to the definition and modify any signatures anymore, right? So everything is slightly cleaner now, right? So I'm not going to add any port. Let me just show you that this works. So let's try Mahmoud 300 or 400, and let's go here and see 400, Mahmoud 400. So this is the implementation of, I don't really need the client anymore, so I'm just going to comment this part, right? This is the implementation of my this is the implementation of our MySQL data access. There is something just missing in the read. We need to say that this is the read, so we return something. So the return value is going obviously to be true. Okay, and that's it, right? We can try to make sure that the read is actually correct. And I'm just going to say do query, or instead of do query, I'm just going to call the read. And table name, I think we did something wrong. So this was self.table name, and this should be table name. Okay, so we have everything working, and the read method that is doing a do query based on a select statement with a return value based on a generic or a dynamic table name. Okay, so all good. We implemented the MySQL data access. Now we want to implement the logic that conditionally creates either MySQL data access or a JSON data access, right? And this is where the gateway or the factory, that's a very cool name actually that I came up with right now, right? So you can just say that this is your conditional creation gateway, right? So let me just go to my class diagram and say, now I'm going to have, actually we modified some stuff. So we added here a table name, we have a driver. You need actually to place the types of every data type of every variable and the data type of every parameter and the return type of every method, but I'm just working as fast as possible. So this is the driver, this is the connection, and this is finally the cursor, right? We have read, we didn't implement delete, so I don't really care about this part, and we didn't implement it there, so we're good to go like this. Right, so this is my SQL data access and my JSON data access. Now we need to have the same idea. We need to have a factory method, right? I'm not going to create a base class or a base data access, but this is the correct implementation. Actually, you need to have a base product. You need to have a base data access in our case, in our use case, that the MySQL is inheriting from and the JSON is inheriting from. Okay, and even if this base class, if you take a look here, there is no common attributes, right? So if you take a look at both of them, there are no common attributes, right? Nothing is common between the variables and the constructor here and the constructor there, but the methods are the same. Read and write and do query, find by. Maybe do query is something that we just added, right? But we can, if the methods are the same, we can just do an abstract class, right? Let me just do this. Right? So I'm just going to say inside data access base data access And this base that access, what is happening? Let me just take this here. Is going to be the parent class. And maybe we didn't do this before, but I think in the object-oriented course you took this concept. So I'm just going to create an abstract class, right? An abstract class in this case, I don't want to share any attributes from it, right? Because sharing attributes or methods are just inheritance. I need an abstract class to define common methods, right, between the childs. But what really matters that it has no concrete, oh my god, implementation, right? So they're just abstract. So whichever class that is going to be, whichever subclass is going to be inheriting from the base class, the abstract base class, data access is going to be implementing all of these methods, right? So these guys share the same prepare connection, read, find by, and find all, right? Let's say that find all and find by are the same for both. Then we can just paste them because this is redundant code, and both of these are essentially violating the dry principle. And find by and find all, right? Because these are redundant. So we can just place these in, right? So I'm just going to remove this client code, right? So you can just place these inside my parent class, just like that. Okay. What is up? Okay. So this is it, and I'm going to remove it from the JSON, and I'm going to remove it from my MySQL. Okay, and I'm going to say that from data access dot, I need the base class, which is base data access. This is the parent, but we didn't actually create anything as an abstract class yet. It's all good. This is just doing inheritance. This is how inheritance looks like. We talked about this in the previous session. We need this import there as well. Okay, so now to continue with our abstract class base case, to make this base data access, this parent base data access class, to make it abstract, right? We are going to make it abstract to say that these methods, the prepare connection, the read and the write, which appears in both MySQL data access and JSON data access, right? They appear in both of them, right? I need them to be implemented, at least these two. I don't care about the write because the write is in one place and it's not in the other, right? But whatever is common between both of them, right? If you have two methods that is common between two classes, right? And these two methods have the same exact logic but with different implementation. So this is the same logic, it connects to something, right? But this is different implementation. This connects to or accesses a file, a JSON file, but it's different implementation. Same thing for the read in JSON case, same thing for the read in the MySQL database server case, right? In this case, you need base classes. You need you need abstract classes, right? So we need abstract classes with abstract method, right? With no concrete implementation, meaning that we need abstract method. And if you remember our talk from the first year software design, if you have a class that contains an abstract method, this makes it as itself an abstract class, right? So you need to say that a class is abstract, right, first before you say that it contains an abstract method, right? And the abstract methods that we are talking about here are the common methods between the MySQL data access and JSON data access that has the same logic, right, but different implementation, right? So in other case, the method that needs to be overridden, right? So this is what we call overriding, right? Overriding means that essentially we can start off with a class, right, with an implementation. It doesn't even have to be an abstract, right? It doesn't have to be an abstract. We can start off with something like this. We can say define read, right? Self and just give it a pass, or any implementation, right? You can say print anything, right? And prepare connection, the same thing, right? So instead of using abstract classes, you can just use inheritance, but just say that these are going to be there, but any subclass is going to be inherited from them is going to override them, right? Override them means that it's going to redefine them, so it's going to appear as the same name in the subclass, but with different implementation, right? So the classes that needs to be overwritten in this case is read and prepare connection. Right? So in Python, to use abstract classes, we can use a module. It's a built-in module. It's called ABC, or abstract classes, right? And we can import ABC and abstract method, right? I think we need to install it. Oh, no, we don't really need to install it. It's built in, but I think I wrote this wrong, right? So it's small letters like that, right? So I'm going to say that the parent inherits from ABC. This is how can you say, first of all, that class, number one, class needs to be abstract before the method. And number two, declare the method as abstract, right? So this needs to be abstract. How? By just in Python, this is at least the syntax in Python, by inheriting from the ABC class. That's number one. This class is abstract. Now this class is an abstract parent class. Now note that abstract classes can contain method with definitions and method with no definitions, or in other words, abstract methods. Right? So let's declare the methods that we need to be overridden, right, in the subclasses as abstract methods. Right? And this is simply by placing the decorator of abstract method above of each method like that, right? That's it. Okay, so to summarize this part, this is just in abstract classes. We just say that point number one, abstract classes is a variation, or is an extra feature. Let's say that is something that you can build upon inheritance. So you need to have inheritance to begin with. That's one. The other thing, you should not and you cannot create an object out of the parent abstract class, right? So a parent abstract class cannot be instantiated. That's the other thing, right? Abstract class, unlike interfaces, right, can have methods with implementation and methods without implementation, or in other words, abstract methods. An abstract class means that it contains at least one or more abstract methods, right? So we say that a class is abstract by inheriting the ABC class, or the abstract class library from Python, and we say that a method is abstract by saying that it has the decorator abstract. Another thing that you need to know is that if you have an abstract class, right, if we have an abstract method in an abstract parent class, all subclasses inheriting from the parent abstract class needs to implement the abstract method, right? Again, if this abstract thing is really annoying you and you don't understand it, you can just omit everything that I've said. Just omit everything. Just omit the abstraction. Just like that, right? You can still override these methods, right? just make it a default parent class that contains some common methods with common implementation for both childs, for both the JSON data access and the MySQL data access, right? Plus, it contains some methods that can be overridden. So whoever is going to take a look at the base class and the base data access and wants to implement a concrete data access for MySQL, for Postgres, for Oracle, he knows that these two are left unimplemented to be overridden in the concrete subclasses, right? So it can be left like this. But I just want to emphasize in the abstraction thing or abstract classes thing, because most of design patterns actually relies on this concept. Okay. So knowing that I'm going to inherit from the parent base data access class, which is an abstract like this, means that I need to have a concrete implementation for the abstract method prepare connection, and I need to have an implementation for the abstract method read, right? Which I already do, but let's just make sure that everything is working. And I'm going to recommend the client code. MySQL data access is not defined. Did we do something wrong? Let us try again. New module called data access layer. I think we messed up something. So the class is called this. Let's try again. I think we need to change the inherited parent as well. Okay, still. Okay, so it was just when we removed this data access from here, it all worked out. So let's try to run this. So it works. Okay, let's try to run the JSON. I'm just going to do this thing from here and just click client code. Let's say that this is going to be this is going to be base, and this is base, and that's going to be taking the user JSON. Let's try to run this, and it works as well. So all good. Now remove the client code from there. Okay. Now we are done. So going back to my class diagram. Okay, so I'm going to follow the same exact setup. Right. So I'm just going to say that this is an abstract class, and abstract actually denoted with an italic here. So this is base data access, and it's going to have a read, and it's going to have prepare connection, and of course the write. Okay, so these are the things that should be existent in both of them. At least the abstract methods needs to be re-implemented or redefined or overridden in the subclasses, the read and the prepare operation. Okay, so I'm just going to say that this inherits and this inherits as well. Okay, and now the factory, I'm just going to call it, instead of factory object, I'm just going to say data access factory object. Let's just call it data access factory. Right, it's going to talk to the base. It can create either this or this, any of the subclasses, or most probably you can just be generic and say it can be either creating this or this, or by the end of the day just a data access type, right? So it can be either this, JSON, or MySQL. And we decided that this is not going to be an association, so that's going to be a create dependency relationship. right? Now in the data access factory, we just need a type. We just need to pass a type, right? DB type or engine type or whatever, right? And this is going to be a string, right? And we just need essentially just one method, create data access object, right? Which just returns what? Returns anything of type base data access, which can be JSON data access or MySQL data access, right? So we can now say that my account entity, first of all, is going to be using associated with the data access factory, and the block is going to be communicated with the data access factory. Okay, now let's implement the data access factory. So I'm just going to remove everything and go to my data access layer, collapse these entities, I don't care about them. I'm just going to say, what is this file? Temporary file, we can delete it. So in the data access layer, we can just say data access factory.py. Okay, so in the data access factory.py, let's start off with defining the class itself. And I know that a symbol factory, right? A symbol factory would mainly need just the method that does the conditional creation, that contains the if statements. If the past type is JSON, then create an object out of this. If the past type is MySQL, then create an object out of this. This is essentially all what we need to do. So this method is really what matters to me the most. So I'm just going to say create, this is the method name, access, or let's just call it create data access object, and it needs a type. So I'm just going to use a constructor here. Not necessarily, I can actually pass the type here, but I just want to use the self object. So I'm just going to say that it is a db type, and if the self db type is JSON, right, then I'm going to create an object out of the JSON class, right? Notice that we're not storing anything, but we need first of all the import. We need to say from the data access layer, import JSON data access class, and from the MySQL data access, import MySQL data access. Okay, that's good. Now we want to create an object out of this in case the type was JSON, right? Okay, let's create a temporary variable that is called created data access object, or created DAO for short, and this is going to be a none. So created DAO. Notice that I'm not storing anything inside a self like this. So there's an object creation, but there is no permanently storage. Okay, so this is not composition. This is, as we said, dependency of type create, dependency relationship of type create. Okay, now I'm going to repeat another if statement and say if it's MySQL, okay, then I'm just going to say create a MySQL data access object. Okay, and finally just return whatever the created DAO would be. You can be more specific and say any return type is going to be of type base data access, right? But I'm not going to do that. Okay, now the beauty of this is that all of the conditional creation, all of the if statements are placed in one place, right? It's just placed in a single function and a single class. So you can actually think, why is this so hard to do? I can just grab this if statement, right, this if block, and go to the entities that needs, right, that access object, and paste them here, right? And if you need a JSON, maybe we would have a type. Let's say that this is a past type, right? So instead of having DB type, I'm just going to say type like this, All right. So if type is JSON, then create a JSON object, and I would need these imports as well. Okay. And if the type is MySQL, then create a MySQL data access, and accordingly store this inside your favorite self objects. Right. So you can do this. Okay. And later on you can use this created DAO. Right. You can place it here, regardless of the type. Right. You can place it here, and you can just keep on doing whatever you were doing from the previous. If you need some kind of to modify the file name or the table name, just say users, just like this, and your life would go on. But the problem with this is that you added a new parameter to the constructor, which you don't really need. This is problem number one. Problem number two is that this is violating. Let's just remove this comment. This is problems. If we didn't have a class that contains the method that does our conditional creation, right? If we didn't implement the design pattern in short for the simple factory, we are violating the dry principle. Why? Because we are repeating ourselves. First of all, we introduced a parameter that is not totally necessary for the account. We don't really need the type, but you just added it to decide if it's JSON, then create a JSON data access object using that table name. And most probably, you're just going to add a new parameter that is table name, right? So instead of having this, you just say table name here and there. Okay, so we added two parameters, right? This is not going to be important, right? And we added coupling, right? By introducing, oh my god, unnecessary composition. This is composition. This is not dependency anymore. This is composition. Right? Because you created an object and you stored it in a permanent variable. So this permanent variable actually can be anywhere outside. You can choose not to make it permanent, but still you would need a method that does that, and it's going to be returning. So if there is no method that returns, then this is just placed in the open air like that, right? Okay, and if this is what you do at the start of the constructor of the entity account class, then this is most probably what you will do at the start of the constructor of any entity account class. Meaning that if you have another entity class like blog, you would violate the try principle, repeat yourself, do the same thing again, and have the same kind of imports again, like this, right? And modify the signature just like you did there. And instead of having that access, then you have two that access or two files like that, and this just your created DAO, and just going here, and you are going to repeat this block in every piece of entity class code, and that's absolutely not necessary, right? So our solution here in this data access factory, we encapsulated everything in one place, which is the create data access method. Right, and to make this follow our object-oriented beautiful paradigm, we put everything in a class, and this class is symbol. This is why it's called a symbol factory object, because any object that is created out of this class simply has just one method that does the conditional creation and encapsulates the conditional if statements inside of it to create objects based on a past parameter, right? Whether to the constructor or to the method itself, it doesn't really matter. It can be coming from the method itself, no one cares. But everything is encapsulated in a single symbol factory. So what happens if, this is the first problem by the way. Another problem, these are the first two problems. The third problem, what if we have a new database engine, right? What if we have Oracle or Postgres? Imagine what you're going to do. You are going just to be repeating your if statements over and over and over, right? So a new if block is going to be introduced just like this, right? And you would have another data access that has CRUD definitions for Oracle-based system, and you're going to import it here. And the same thing that you did there, this edit that you made in the account entity class, is going to be also made in what? in the block entity class. And if you remember our talk about the solid principle, the one that I've just talked about briefly, and I just said that, you know, don't worry about it because we didn't talk about it inside the lab. This also violates the open principle, the open and closed. Nothing is closed for modification. Everything is just open to modification. If you didn't modify this here in this account, and if you didn't modify and add this part in the blog, right, the code is non-robust and it's going to be broken easily. It's going to crash easily, right? And if you, same case, if you forgot any of the imports, right? So this is why this is a bad refactor, right? If you did everything in an if statement, conditional if statement that is not encapsulated into a method, that is not encapsulated into a class, right? So this is how the simple factory solves everything. You can put all of the if statements in one place, and if you want for any reason to add a new type that is going to be conditionally created, just come to the point of focus, the point of contact here, which is the data access factory. Come to this class, add an else if, and add another else if. Maybe you have Oracle, maybe later on you have Firebase, right? So you have Firebase data access, and keep on adding else ifs and conditional branching as much as you want in one place. This is the beauty of it. This is how we can say that we have from this part, right, we have abided by, right, we have abided by the open close principle, right? So we are open for extensions. Extensions mean that what if we want to introduce a new type, a conditional branch that contains Firebase, Postgres, Oracle. So we're open for extensions, and we are closed for modifications, right? So you're not going to modify anywhere in the code. You're not going to go to the account and modify in the constructor of it, or the blog and modify in the constructor of it. Just modify in one place, the one that where you are going to introduce the extensions, right? Abiding by the dry principle. We're not repeating ourselves all over the places like this in account and in blog, right? And that's essentially the point of using the simple factory pattern, right? So I'm just going to delete that because we don't really have these two cases. I'm going to go to my previous implementation. Okay, in the account. Okay, so this is how things were previously. Now let's continue our data access factory. Now you know that the JSON data access requires, as you can see here, it requires as a parameter the file name, which is equivalent to the file JSON file, and this requires two things: the driver and the file name, which is equivalent to the table name. So I'm just going to need the table name for both of them, right? So this is the table name or the file name, and this needs a table name. First of all, let's work out the driver that data access, the MySQL data access needs. So this essentially needed a driver, right? And we can just take the driver from here and actually put it here in this case because we're going to need it, right? So I'm just going to pass the driver. So this is the driver that I'm going to pass. Okay, and later on I need the table name, so I can just take the table name here from the constructor and store it inside a variable, a temporary, a permanent variable, right? And just take this table name and pass it to the JSON.access and pass it to your favorite MySQL data access. But remember, MySQL data access, the constructor, takes driver and table name and the quarks, right? Which are the essential stuff that's going to be passed to the prepare connection, that is going to be passed to the connect method from the driver, from the connection object, right? And if you remember, this is how my object creation looked like, right? So we pass all of these needed parameters, right? So I'm just going to pass these parameters. Okay, just like that. And we're good to go. There's a problem. Connected table name. There's a comma here. Okay. and I'm going to comment this part out again. Okay, so this is my created DAO if it's MySQL. This is my created DAO if it's JSON. Now you would ask yourself, who is the client? Who's going to be using this class, creating an object out of this class and passing to its constructor the needed type and the needed table name? I would tell you that the one that is going to be doing this, first of all, the entities are going to be associated with it. So the entities needs to have a sent object. So if I told you if the association is going like this means that it's reversibly an object of data access factory is being sent to this account entity, and an object of the data access factory is sent to the log entity. So essentially, instead of communicating with our base data access or a concrete data access product from the entities themselves, we're talking to the factory now, to the factory class. So we would need a factory object, right, which is of type data access factory in both entities. This is what the association means, right? We're not talking to any of them, either the base, the abstract, or the concrete data access objects. We're talking with the factory. And inside the factory, we're going to call create data access, right? The client who's going to be calling this method is these two entities, okay? Creating accordingly based on the past parameter, based on the past or injected type, the JSON data access or the MySQL data access, right? We just added a couple of things here. We added a table name. I think that's it, okay? Okay, so let's go to the entity. So where is the entities? Here, the account. So first of all, I'm just going to say that this is going to be a factory object. And once I have the factory object, right, you can actually store it, since this is association, right? If I have the factory object, right, I can just say, actually, I don't really need to store it, do I? But I'm going to store it just for the sake of, you know, because we need to denote the association, right? So we can just say from the factory object create, we can call the create data access method, right? This is what really matters here. This is the, I'll just take this part, okay? This is the client where we are using the factory method from the simple factory object class, okay? Now we can create the data access object, and this created data access object, no one knows for the time being which is going to be, right? Because we need to create an object of the data factory and pass the type to it and the table name to it. If you notice, I'm using dependency injection, and in dependency injection, I don't really care about the constructor. I don't really care what is being passed to this object when it's being created. I just need to create it elsewhere, somewhere else, right? And in this case, we just mean here that it's going to be created in the app by the client. And once it's created with its needed type and with its needed table name, just pass it to the relevant or the respective entities. So once it's created in the app.py with the type and the table name, just pass the created factory object to my entity. And once it's reached the entity is going to create an data access object from it, right? And if we created an data access object out of it, we can just, right, store it. And instead of this, instead of relying on the data access object, this was the previous implementation, it was just this part. So instead of this, now we would just say from the factory object create the data access object, okay? And if it was previously in the factory object itself, if you passed a user to JSON or a user table in general, regardless if this is MySQL or JSON, then you would create a data access for this table accordingly based on the type. Okay, actually we don't really need the self, right? We don't really need the self as well. So I can just take it from there and say factory object.create, okay? And since we don't really store it in a self, actually what can be actually done, we can just make this a use dependency. It's another dependency relationship of type use, and the reason I used it to be used because we didn't really store anything, right? So we didn't really store a data access factory object inside of it. We just took it from there, right, and used it to create that access object. And it's just whenever this constructor is finished executing, it's just this is going to die because I did not store it in a self.factory object. I removed the self.factory thing. Okay, so we actually don't have a permanent reference, so I'm just going to delete that permanent reference and accordingly modify my relationships to be an dependency of type use. Okay, so if I did this here, I'm going to do the same exact thing in my blog, in my other entity. So instead of having data access object, I'm just going to call this factory object, right? And this is going to be in place of data access object. And I'm going to call the create data access method, which is going to create your blog, my data access object for the blocks table. Okay, now the moment of truth come to the Apple Pie, and this is where we need to wire everything together and give concrete values to my factory, right? So I'm just going to, I don't really need to import any of the data access. This is the beauty of it. So if I previously had JSON and I added, like, you know, I added MySQL data access class, right? I wouldn't necessarily need to import every data access based on the data storage or database storage type that we introduce in the system. We just need to import only one thing, which is the factory, the data access factory, that is going internally to create any of the needed data access objects based on the different database storage, right? So I'm just going to import the data access factory from there, and then I'm just going to say this is data access. You can just leave this like that. So once you have the data access, and instead of having these, see, I'm just going to say data access factory. And what do you need? We need users, and we need something for the blocks table. But what is the database storage? This is where we need to specify a database type and a table name, right? Well, let's say for this, for whoever is going to be implementing these are going to use these two features or implement the features now, the developer is going to decide, or the company or the organization is going to be deciding that for the current implementation we need to use the JSON, for example, the JSON format, right? So I'm just going to provide the database type to be JSON, and I need the table name, which is once is going to be users, right, and the other is going to be what is going to be blocks, right? And what's going to happen is that I'm going just to replace this part with this part, okay, and replace this part with this part. Okay, so we created the factory. So this is the user data access factory object. This is the same thing, right? And once we send the factory objects to the entity class, right, inside of the entity it's going to create using the, using the past parameters, data type, database type, and the table name, right, that we have passed externally in the main client applet py. Inside the entity, I'm just going to take this factory object and use the main method, right, the factory method that is going to be creating data access object based on the past parameters here. Okay, and this is going to be for the block. Okay, that's essentially the implementation. If we run this, we should have an error. Let's see what is the error here. So it comes from no module called base data access. So it's what's the base class. Let me just see this. Okay, so it's nothing. It just seems that whenever we were in the subclasses in the child MySQL data access, it needed the base data access. So we needed to provide the folder name, the containing folder name, right? So everything is inside data access, and you can find the base data access from it, right? Same thing for the JSON data access, and you can find the base data access from this folder, right? Okay, going back to the applet py, let's try out the login. Let's log in with something that I know that is there. It works. Let's view his stuff. Okay, so I think we removed something here. This is in the find all, so let's just check the Well, the video is done here, so if you want to leave, this is it. But I just want to show you a complete run sample. So where was that? I think it was in the base. We removed something. Yeah. Okay, let's try this one more time. So I'm going to log in. Okay, and I'm going to view post or view blog post VB, and these are my blog posts, right? That is inside my JSON. Okay, so this user, which is Halak blogs, he has this one, he has this one, he has 3 essentially, or 4 and 5. Okay, now let's try to check the the database, the MySQL database instead of the JSON thing. So this is the user that I'm going to try to log in with, and this is the blogs that I want to see: Wandering the Earth and Amazing Adventures. Right, so let's try to modify this. Go to the app.py. See how this is easy. I'm just going to say MySQL here and MySQL there, and that's it. The same table names, right? So let's run this and log in. Hopefully this will work. And we have logged in. Now let's try to view post, and these are the posts that I have in my SQL database server. Only two, Wandering the Earth and Amazing Adventures, and that's it.